All right, so let's talk about longshore drift. This is a process of transportation. Again, it's a very, very common type of exam question, and it's a process. So think of it in step by steps. You need that key vocabulary as always, if you're going to be able to answer this question and get the marks. So let's talk about it. So let's clear up a few things before we get stuck into the actual classic process. So the first thing you need to know, and you should know this from kind of land formation, is that we obviously have our waves. Our waves contain energy, and as they reach our coastline, they roll up the beach. We call this swash, okay? Swash is when they move up the beach. But then again, what goes up must come down. They go rushing up the beach, they lose their energy, and then they are pulled back down, and we call this backwash. So swash up the beach and backwash down the beach. That is really important to this process, and we'll return to why that is. So please know backwash and please know swash and what they are. The next is the prevailing wind, okay? Because as we know from looking at waves, waves come from friction. Yep, and so the prevailing wind is the most common direction of the wind, and really that dictates the direction that waves travel. So waves will often hit our beach at an angle due to the prevailing wind and the friction they create, okay? So please know the waves often hit at an angle due to the prevailing wind. We also need to know swash and backwash, okay? Right, let's jump into the actual process. We'll break and understand why this is relevant. All right, so we understand swash and backwash, and we understand prevailing wind. All right, these are very essential components of this process. So let's not forget, in this diagram, north, east, south, west, our prevailing wind, okay, is here. So our waves are traveling in this direction. All right, that's going to be really important because it's going to dictate and decide the direction of longshore drift. So, what happens? The angle of wave approach is the language we're going to use, but that's really just a fancy way to saying the waves are hitting the beach at an angle. So the swash will go up the beach like so. So the swash goes up. The energy from that is the waves. But the backwash, energy for that is coming from gravitational potential energy being turned into kinetic energy. So that happens in a perpendicular angle to the beach, which essentially means parallel to, okay? Or at a right angle of would be even better language, okay? So that's what's happening. Well, what the hell does this have to do with transportation? So now we need to talk about sediment, because all of this whole process is about transporting, moving, sediment. So sediment is tiny pieces of eroded rock. Now obviously I've drawn them as yellow, okay? That's our beach, okay? That's what's being moved. So then the cycle repeats itself. The swash from the wave hits the beach at an angle, and in doing so, it washes that sediment up the beach. And then again, at a right angle or perpendicular, the swash takes effect, and the swash drags it down the beach. And this happens in a cycle, again and again, continuously. It's happening all the time. It's happening on every beach pretty much right now as we watch this video, okay? And every time this happens, swash, backwash. Last one, swash, backwash. Every time this happens, the sediments are moved, okay? A little bit at a time, wave by wave, they are moved, and then they are transported, okay? So we can see our piece of sediment has gone from A to B, okay? And that's pretty much longshore drift. It tends to be a a process that kids actually don't mind. But again, I'll flash the keywords that you need to know for this process right now. Pause it, have a look, make sure you understand all of them, and just know that it is a cycle. The energy comes from the wave, but also gravity and kinetic energy. It's dictated by the prevailing wind, all right? And this is all taking place on our coastline, all right? That's Longshore Drift. All right, so let's just quickly add a bar and a tombolo to the knowledge we've been talking about. They tend to come up in exam questions, again, when we're talking about depositional coastal features, and they're nice options to write about. I actually think the tombolo is easier than the spit, so I encourage my kids to talk about this one, so we'll get into it. So let's talk about the bar and lagoon first, though. We see here, this is our river. We have our ocean. I hope you know when a river meets the ocean, we call it the mouth. So here's the mouth of the river. What's essentially going to happen is it's going to get closed in. So we have longshore drift, swash and backwash happening in a zigzag motion. And again, once it gets to the mouth of the river, the waves will dissipate and break up. And so there's not enough energy to continue to transport the sediment, and so it starts to deposit it. Now what happens is it deposits it over time and essentially blocks in the river. So behind it forms a lagoon. And yeah, that's essentially what happens. This doesn't always happen. A river like the Thames, for example, if we look at England, doesn't take place because the river is just too powerful, okay? But a smaller river can form a lagoon if it is blocked in by deposition. And then what happens is then transportation then can continue, okay? So new land is formed and created by the deposition. The next one is the tombolo. Now the thing to know about the tombolo is, just like in our previous section, there's a change in the direction of the coastline. We can see that there is an island off of our mainland. So you can probably kind of see what's going to happen. Longshore drift will take place in a zigzag motion, as it does. As it reaches that change in coastline, the waves will dissipate, they'll lose their energy. And so this sediment will start to be deposited, and look what happens. All that happens is that a beach, a bar, is created between the mainland and the island. And eventually what will happen, same thing with kind of sand dune succession, is that vegetation will grow, that will become soil, and eventually this will just become land, and that will no longer be an island at all, okay? So these are two additional depositional coastal features that fit really well with longshore drift and transportation, okay? The words that you kind of need, again, are lagoon, the mouth of the river, maybe closed in and things like this, and then here you just need island, mainland, and change in direction. So they're nice options to have for you to add to your bank of things that you can talk about in an exam, okay? We're now going to jump into an exam question that looks at longshore drift and the formation of spits. I hope you found it useful.